So the temperature on a given day in April is given by T equals 17 minus 4 sine pi over 12 T, where T is the time in hours after midnight. What was the temperature at midnight? Okay, so how did you do that one?
So it'll be when T equals 0.
Yeah, so it's just when your small t is 0, right? And then, so what did that come out to be?
Let T equals 0, and then it'll be 17 minus 4 sine 0. And then that
Yep.
will be
What's sine of 0?
0.
Yep. So remember sine of 0, so on a unit circle, 0 is here, and sine gives us the vertical component. So if this is your line, the vertical component is 0. So sine 0 would just be 0. Yep, so we're doing 17 minus 4 times 0 essentially. So that's 17 degrees.
Yep.
So at midnight, it's going to be 17 degrees. Okay, and then what's part B? Minimum temperature during the day, and at what time did it occur? Okay, so how do we get the minimum temperature?
You can, just do 17 minus 4.
Yeah, and the reason we do that is the max value that sine of an angle can take is 1, right? So the max this can ever be is 1. So you're just replacing that by 1. Yep, good. And then so 17 minus 4 is just 13 degrees. And then we want to know at what time did it occur. So we need to think about when does sine, when would this equal? So we want to know at what time can that happen. So sine of what angle equals 1?
Pi on 2.
Pi on 2. Okay, so that means when this is pi on 2, sine of that equals 1. So, and this has to equal pi on 2, right?
Yeah.
So pi t over 12 has to equal pi on 2 for sine of that to equal 1. So now if you just solve for that, so that's multiply both sides by 12 and you get 12 over 2 equals t. So t equals 6. So at what time? At 6 a.m.
Yeah. Wait, why do you do like sine pi t over 12 like equals 1 again?
So we want to know the minimum temperature, right?
Yeah.
For the temperature to be minimum, we need to minus 4 from 17. To minus 4 from 17, we need this part, sine of pi t over 12, to equal 1.
Oh, okay.
Because that's the max, that's what's going to make it minimum. Okay, and then over what interval did the temperature vary that day?
Is that just the period?
Not the period, the temperature, so the range.
Oh, yeah.
So if I just, one second, I'm just going to make some space. So for C, think about it. So if we graph this, 17 is like our middle equilibrium point.
Yeah.
And then we're going, our range is like 4. We're going 4 up and down from here.
Yeah. So it's 21 and 4.
So yeah, so like the max we can ever be is 21 and the minimum will ever be is 13. So what interval did it vary? Between, so we can say between 13 degrees and or to 21 degrees Celsius. Okay, and then what's D asking us for? State the period and sketch the graph of the temperature for T between 0 and 24. When you get it in this form, then you can graph it.
Yeah.
Right? So the first thing is let's get the period. So how do you get the period?
So we 2 pi
Over B should be the period, right?
Yeah.
Okay, so we did 2 pi over. So the B in this is pi over 12.
Yeah.
So that's 2 pi times 12 over pi. Yep, this cancels. Okay, that works out really well. So the period is actually 24.
Yeah.
24 hours. So the whole day is what it takes to do one complete cycle. And then sketch the graph of the temperature for T between 0 and 24. So if we are graphing it then,
Yeah.
what's A? So if I write it in this form, it's going to be negative 4 sine pi on 12 like T. There's no C. Like C is essentially 0.
Yeah.
All right. So if this is our graph, say this is 0, well, we are going to be at 17. And then our period is going to be 24, right? So just to keep in mind, that's our middle point of our graph, like the equilibrium point. The max will be at 21 and the lowest will be at 13.
Yeah.
Now to graph it, what do we need to do between 0 and 24? We need to split that into 4.
Yeah, so only like 6 and
So
12.
yeah, so every 6 hours, we're going to have like a minimum, middle, maximum, middle, right? Okay, also note it's a negative 4. So like a normal sine graph does this, right?
Yeah.
When you have a negative, it gets flipped. So it's going to do this. So we're going to go down first. So from 17, we're going to go at 6. We're going to be at the minimum point at 13.
Yeah.
At 12, we're going to come back to the center. At 18, we're going to be at positive 21. And then at 24, we'll come back to the center at 17.
Yeah.
And then we can just connect them up. Now, so this is like time after midnight. And then this is the temperature in Celsius. Great, so that's D. And then for E, if the temperature was below K degrees for 2.4 hours, obtain the value of K to 1 decimal place. There is some value K for the temperature. Let's call that K. For the time between it, this was 2.4 hours. The temperature was below this point.
Yeah.
So we need to find what's that value of K, because if this is our center, right? Like this is our middle. So this point here is 1.2 hours less than 6. So this point would be 6 minus 1.2, which is 4.8. And this point on the graph here would be 7.2.
Yeah.
It's a symmetrical graph. So when it's below K for 2.4 hours, your like middle point is still going to be 6 hours. If you halve 2.4, you get 1.2. So if you do 6 minus 1.2, that's going to give you 4.8. So this point here is at 4.8 hours. And then when you add 1.2 to 6, you get 7.2. So that's your other point here.
Yeah.
So now you just want to find your K value at 4.8. You just find what's T at time equals 4.8. T equals 17 minus 4 sine pi over 12 times 4.8. That should give you the answer.
Yeah.
And it says to 1 decimal place, so you can use a calculator for this.
It'll be 13.2.
13.2 degrees. All right. If you want to do a sanity check, plug in 7.2 and you should get the same answer.
Yeah. Yeah, it's the same.
Yeah, cool. So that means your K, this here, this temperature is 13.2 degrees. Below 13.2 degrees, the temperature stays below 13.2 degrees for 2.4 hours between 4.8 hours after midnight to 7.2 hours after midnight.